Hello student of grade 11. Today we'll do exercise 2.2 based on relation. They've given a set A as 1 till 14 and the relation is defined as R xy such that 3x minus y equal to 0. So we're going to find the relation and we're going to write the domain, codomain and range. So we'll take this equation 3x minus y and try to find the value of y. If I take 3x on the other side, it is minus 3x. Both sides negative cancel, so y is 3x. Let's get the relation. If I put 1 in place of x, I get 3 into 1 is 3. So second one, if I put in place of x2, I get 6. So second relation is 2 is 6. Similarly, if I put y equal to 3, I get 9. So 3 is 9. If I put 4, it will be 12. If I put 5, it will be 15. But 15 is not in the set A. So I cannot put 5. So maximum it can go 12. If I put 4, it is 12. 3 into 4 will be 12. Now, you have to write the domain. Domain of R. The first element is the domain. That is, I can write 1, 2, 3, 4. And range is the second element, that is 3, 6, 9, 12. And codomain will be set A only because the relation is from A to A and the second set is a codomain. So it will be set A only. Clear? Let's go to second question. Define a relation R on the set N, means natural number, by R such that xy and y equal to x plus 5. X is a natural number less than 4. So value of x can be 1, 2, 3. Now you're going to find a relation such that y is given as x plus 5. So relation will be y is given x plus 5. That means in place of x you can put 1. If I put 1 I get 6. If I put 2 I get 7. If I put 3 I get 8. So relation will be 1, 6, 2, 7, 3, 8. The question is to find write down the domain and range. So domain will be the first element, that is 1, 2 and 3. Range of R will be second element 6, 7, 8. Let's go to third question. They've given A is 1, 2, 3, 5, B is 4, 6, 9. Define a relation R from A to B. R is xy. The difference between x and y is odd. So relation is from A to B, and if I minus this, I must get odd. Clear? X belong here, y belong here. So solution. Now I have to take this and this, okay? If I take 1 and 4 and I subtract 4 minus 1 is 3, odd number. Likewise, I can take 1 and 6. If I minus, I get 5, odd number. The difference between x and y is odd. We have to show that. If I take 1 and 9, I cannot take because 9 and 1, if I subtract, I get 8. So it's not odd. So I can take 2 and 2, 4, subtract, we get even. 2, 6, if we subtract, we get even number. 2 and 9, 9 minus 2 is odd, 7. So I can take 2, 9. Let's do it. 3 and 4 we can take. If I subtract, I get odd number. 3 and 6 I can take. If I subtract, I get odd number. 3 and 9 I cannot take. I cannot take because I get even number. Let's go 5 and 4. Yes. 5, 4 we get odd number. 5 and 6 will get odd number. 5 and 9 we get 4. Difference is 4. So this is the set of relation. Okay. Now your question is write in the roster form. So we got in the roster form. You don't have to find domain and range. So answer is this one. Okay. If they ask you to find domain and range, domain will be 1, 2, 3, 4, 3, 5. Range will be 4, 6, 9. Everything. Next, go to next question. Question number 4. They have given a relation with with arrow diagram. Okay. 5 is related to 3, 6 is related to 4, 7 is related to 5. You have to give this situation in set builder form. So set builder form is simple. Roster form, set builder form, and domain and range. So roster is directly, we can say 5 related to 3, 5 is related to 3, 6 is related to 4, and 7 is related to 5. Domain and range also we can find. The first element is domain. 5, 6, 7. Range is 3, 4, 5. Let us write in the roster form. Set builder form. Now you'll see that we can write that R equal to you'll see that this y is 2 less than 3. So we can write y is x minus 2. If x is 5, we get y as this one as 3. That means minus 2. So we can write y is 2 less than x. Clear? And the value of x is 5, 6, 7. This is in set builder form. Roster form is given. Domain and range is done. Okay. Let's go to question number 5. A is given. Let R be the relation from A defined by AB. AB belong to A. B is exactly divisible by A. B means this second number is divisible by A. You have to write. Okay. So R will be, and the relation is from A to A. That means I can use this element only. You have to get a first number, divide the second number. So 1 can divide everything. So I can write 1, 1. I can write 1, 2. I can write 1, 3. 1, 4. 1, 6. Because 1 can divide everything. Then I can write 2, 2. Then 2 cannot divide 3. 2 can divide 4. So 2, 4. And 2, 6. Then 3, 3. 3 cannot divide 4. 3 can divide 6. So 3, 6. 4, 4. 4 can divide 4. And 4, 6 we cannot write 6, 6. Okay. So these are the relation. The first number can divide the second number. Since the relation is f from A to A, I can use only these numbers only. So what is the domain? The first element 1, 1 2 3 4 6. We have 1 in the first element, 2 also is there, 3 also is there, 4 and 6. Range of R will be we have 1 2 3 4 6, everything clear. So done. Let's do question number 6. Determine the domain and range of the relation defined by this. So first find the relation, then we can find the domain and range. So it's given that if first element is x, second element is x plus 5, and the value of x is 1 to 5. So if 0 to 5, if I take 0, the second element will be 0 plus 5, that is 0 is 5. If I take 1, the second element will be 1 plus 5, that is it will become 1 6. So second element is 5 more than the first element. So what we can have the set, if I write 0, I get 5. If I write 1, second element is 5 more, so it will be 6. If I write 2, second element is 5 more, 7. If I write 3, second element is 5 4, 8. I can use still 5. If I write 4, I'll get 9. If I use 5, I'll get 10. Now find the domain and range. The first element is the domain, that is 0 1 2 3 4 5. Range of R, the second element, so 5 6 7 8 9 10. Let's go to question number 7. Similar, okay, they have given x is, the second element is x cubed. First identify the prime number below 10. So prime numbers are 2 3 5 7. These are 4 prime number, okay. So x can be 2 3 5 7. So let us write the relation. If the first element is 2, the second element is cube, 2 cube, that is 8. 2 is 2 cube, like that. 3 will be 3 cube. So if the first element is 3, second element will be 3 cube, that is 27. If the first element is 4, second element will be 4 cube, that is 64. If the first element is 5, second element is 5 cube. Oh, we don't need 4, okay, we have to use 5. And 7 is 7 cube, that is 343. So this is a relation, okay. You have to write in roster form. We got in roster form, so that's the answer. Let's go to next question. Question number 8. A has 3 elements and B has 2 elements. Find the number of relation from A to B. First, in a cross product, how many elements we will get? We'll find out, okay. So this will be 3 into 2. So there must be 6 elements in the Cartesian product of A and B. A cross B will get 6 elements, like x1, x2, y1, y2, z1, z2. So we'll get 6 elements. Now, to find the number of relation from A to B is like we're finding the number of subset. To find the number of subset, formula is 2 power n. So power n means 6. N is 6. So how much you'll get? 64. You do 2 into 2 into 2 into 2 into 2 6 times, you'll get 64. Let's go to next question. Question number 9. Let R be the relation on Z. Z means integer, okay? Defined by R, A, B, and the condition given is A minus B is integer. You have to know that when you subtract any integer, we get integer only. Clear? So relation will be AB. They've given A minus B is integers. So domain will be, we subtract any integer, we get integer. So domain also will be integers. Range also will be in integers. Okay, negative number, positive number, everything will be integers. Clear? Let's go to, you have to find the domain and range. So simple. If I use A and B integer and subtract, we get integer. So it satisfies. Every time you take two integers, we'll get integers only. The first number also, domain will be also integers. Second number also will be integers. Clear? For example, if I take 2, 5, 2 minus 5 is minus 3. This is also integer, this is also integer, this is also integers. So it's satisfied. So the domain also become integers. Even the range also become integers. Okay. Let's go to, oh sorry, this is the last question of exercise 2.2. Next video I'll do some extra question of exercise 2.2. Please pause the video to write everything. Thank you.